The problem here says find the minimum and maximum values of the expression. In number 29, the expression is x plus 2y, where x and y are the lengths that are shown in this figure, and x is between 0 and 10. So that's kind of an abstract geometric problem. You are trying to find minimum and maximum values, evidently of some function, but what's the function? It's x plus 2y, that's the function, but y does depend on x. The picture tells you how y depends on x. So we've got, let me redraw the picture here. X is this length, y is this length. This distance from here to evidently directly under that point is 10. The units are not given. In a real life practical problem, you would want to think about units. And this distance is labeled as a 5. We're trying to minimize x plus 2y and maximize it, where x is between 0 and 10. In effect, what we were saying is what value of x will minimize the sum of these two distances. Should x be real small and y be big, giving us a picture like this? Watch my hand here, like this, and then up that way. Or should x be real big and y be relatively small, like close to 5, so that our picture is more like this? This is actually a fairly practical problem, and oftentimes it's solved even by animals. What? This is solved by animals? Yes, you can look it up. There's a dog that even came to Bethel once, put on a show for us about, I think it was 15 years ago or so. You can look this up, maybe in the Clarion. This dog is relatively famous because an article was written about the dog, how when the owner took the dog to the beach, pretend the beach is down here underneath this line, and the owner threw a frisbee or a stick into the water, not straight out into the water, but at an angle, the dog would run along the beach a certain distance before jumping in the water to swim to minimize something. The dog did it naturally. What was the dog trying to minimize? I don't remember. The one thing the dog could minimize would be the total distance traveled. Probably that was not what was minimized. Probably the dog tried to minimize either the time of travel or the energy expended. The dog can run faster on land than it can swim in the water. That's one thing to consider. And it's also more tiring. It uses more energy to swim in the water. So the dog unconsciously, subconsciously figured out where to jump in the water to minimize something. Would people do that? Well, you might say dogs are smarter than people that way. I don't know. Probably you would do it in some intuitive way without really knowing what you're doing. It's a practical kind of thing. Comes up for military campaigns. You're in some tanks, you got to get from point A to point B. This is ordinary land here. Maybe this is a marsh here. Harder to get through a marsh, more costly, slower, that kind of thing. This is a practical kind of problem. But to do it, you got to add more to your drawing here. You got to draw a right triangle. That's supposed to be a big hint of how to solve it. You got to use the Pythagorean theorem because that's a right triangle. Do you need to think about angles? Not really, because you can figure out how y depends on x without thinking about angles, other than realizing that's a right angle right there. And if this distance right here is x, that means this distance must be 10 minus x. The Pythagorean theorem would say the square of the hypotenuse is equal to the sum of the squares of the other two sides. And that means you can solve for y in terms of x, take the positive square root, because y has to be positive. Should you expand that out? It's actually probably not a big deal if you don't. It might even be easier if you don't. You could expand it out. It's not a real big deal, one way or the other. I'll go ahead and write what it would equal if you expand it out just for good measure. 10 squared is 100, plus 25 is 125. We'd also have a minus 20x and a plus x squared. This effectively is your constraint. The Pythagorean theorem and the fact that this side has a fixed length of 5 means that y cannot vary independently of x. Y does depend on x, and therefore you can go back up here and replace this y with its dependence on x for the purposes of minimization and maximization. So because of that, the function we want to maximize and minimize is f of x equals x plus 2y, x plus 2 times the square root. I'll go ahead and use the expanded versions, but again, it's not a big deal either way. And the interval is 0 to 10. This is a closed interval, so we will have to figure out the critical points and plug in the critical points and the endpoints into the function to see which gives us the minimum and the maximum. The derivative will be 1 plus 2 times square root is the same as a 1/2 power. Bring down that 1/2. 1/2 minus 1 is negative 1/2. Don't forget the chain rule, multiply times the derivative of the inside, which is this. We want to set this equal to 0 and solve for x. Doesn't look so easy, does it? The 2's there cancel. Let me leave the 1 on the left side. Let me bring everything else to the other side. I can write it as a fraction, and if I bring it to the other side, I have to change the signs of these two quantities if it's going to be on the other side. So I'd have 20 minus 2x over this thing on the bottom as a square root. That still looks fairly complicated, but it's actually it's easier than it looks. If this fraction equals 1, it means the top and the bottom have to be equal. You can cross multiply. You can also square first to get rid of the square root. 1 squared is 1. I don't know. This needs to be squared. Like that. And yeah, effectively cross multiply and expand this out. 20 squared is 400. We would get a minus 80x plus 4x squared. In the end, it looks like we're going to get a quadratic equation to solve. 0 equals if I subtract x squared from both sides, I get a 3x squared on the right. If I add 20x to both sides, I get a minus 60x on the right. And if I subtract 125 from both sides, I get a plus 275. I subtracted x squared from both sides. I added 20x to both sides, and I subtracted 125. Can this be factored? Possibly, but it's not real clear what it might be. Let me just use the quadratic formula. X would be 60 plus or minus the square root of negative 60 squared. It would be 3,600 minus 4 times 3 times 275 all over 2 times 3. 60 over 2 times 3 is 60 over 6 is 10. Hopefully the square root is a real number. Well, I mean, even if it weren't, it would just mean there are no real critical points. 12 times 275 is indeed less than 3,600. 3,600 minus that is 300. It's not a perfect square, so it's not technically a nice number in the end here, but it is what it is. Let's just go ahead and approximate these things. We do want the critical point to be between 0 and 10. Actually, that means we'd have to take the minus, wouldn't we? the critical point between 0 and 10 critical point in the interval from 0 to 10, that's a C here, critical point, is 10 minus square root of 300 over 6. Could you simplify that fraction? Yes, but I'm not going to bother. Square root of 300, about 17.32 divided by 6, subtract that from 10. It's about 7.11325. We'd want to plug that number as well as the endpoints back into the function. What function? That one. Sorry. It is what it is. Okay, plugging in 0 is not too bad. F of 0 would be 0 plus 2 times the square root of 125. F of 0 is 0 plus 2 times the square root of 125. Square root of 125 times 2, that's about 22.36. F of the critical point, 7.11325, that'll be 7.11325 plus 2 times the square root of 125 minus 20 times 7.11325 plus 7.11325 squared. I'm using the formula for F when I write that down. Not a super pleasant thing to calculate, but yeah, again, that's life sometimes. 125 minus 20 times 7.11325 plus 7.11325 squared. Take the square root of that, multiply times 2, and add the 7.11325. I have now made a mistake. It's about 18.66. 18.66. And then F of 10, the right endpoint, is going to be 10 plus 2 times the square root of 125 minus 20 times 10 plus 10 squared. 10 squared is 100, 20 times 10 is 200, minus 200 plus 100 is minus 100. Oh, that's a 25. This turns out to be a nice number here. Square root of 25 is 5. Looks like we get 20. So the total distance, minimum distance, is 18.66 when x is about 7.11325. And the maximum distance, 22.36 when x is 0. So if you were trying to minimize distance, if this distance is 10, you want x to be about 7.1, you'd want to go to about here before going up like that. If you're trying to maximize distance, you do a slant right away. X is 0. That'll maximize the distance. Right, that doesn't make sense. Oh, no, we're not trying to maximize distance, sorry. We're trying to maximize x plus 2y. So we're not trying to minimize distance. You know, this might be more realistic for trying to minimize time of travel or energy expenditure. Time of travel, if you go twice as slow over this length than this length. Because the two. Okay, so it really is a practical kind of problem.